Our first thing is we were working with SMU on the National Geothermal Data Aggregation, and this helped a great deal. First of all, in putting together the SMU and the International Heat Flow Commission databases, we cleaned up a lot of information in there. So it's a very useful thing, and this is all available. We worked with them and with the Arizona Geological Survey for the bottom hole temperature templates, thermal conductivity templates, temperature versus depth templates, also with the temperature depth plots in the data, and we generated a radioactive heat production template. So all of that is there. And one thing I'd like to point out is we used a lot of people. I hope you can see everything here. My screen shows, yeah, there we go. Here are 15 of the students we had in our program. A lot of bachelor's degree students, a lot of master's degree students, and these people worked throughout the program entering an incredible amount of data because we had all of the bottom hole temperature data from oil producing states, and that's a huge job. We also involved a lot of faculty in this, and I'll just point out we've established a geothermal laboratory. We have 6 faculty involved. We have 5 PhD students, 2 of whom have already finished, 3 more will finish this year. And we had 8 master's degree students. Most of those are finished. We still have 3 in the pipeline. With Minnesota, we generated a heat flow map, a thermal conductivity map, and I'm trying to move this, oh good. Radioactive heat production map. We have maps for uranium, thorium, and potassium throughout the state. And we have a number of temperature depth plots, and I'll show you those. Some of the products that came out of this, of course, Rob Klenner's master's thesis on Minnesota heat flow, very much changing the picture of what's going on in Minnesota as far as geothermal resources. The Natural Resources Research Institute heat flow map of Minnesota, and the publication that came out of that is a really fine piece of work. And we also have a senior student working on a thesis on thorium in Minnesota, thinking that they might have some sort of resource there that's economic. Again, this all came out of working on their database. This is some of the data we collected in Minnesota. The sites with the heat flow values are in the lower left-hand corner, and the temperature depth plots from all of those holes are shown on the right. An interesting thing about it is it has an incredible climate change signal in it. One thing you can do is do a least squares fit of the bottom parts of these temperature gradient plots. Like here's the one for the northern section. The surface intercept tells you what the surface temperature was perceived by those holes at the bottom. This is the middle part of the state, and here's the holes in the northern part of or the southern part of the state. So we can see a little bit of climate shift. But this is an amazing thing that came out of it that we did not really plan for in the beginning. Nebraska, again, bottom hole temperature from an oil producing state. We had a lot of heat flow data from there, so we've compiled that data. It's submitted to the database. Temperature versus depth plots and temperature versus depth data, and we georeferenced the old NOAA geothermal resource map. I know Alaska mentioned their map as well, but this is from that time, from 1983. Things that have come out, we've got a new heat flow map for Nebraska. We have a master's thesis that we'll be finishing up this fall. Anna Corral's produced a couple of papers on that, especially on the bottom hole temperature corrections. Just a picture of what the data are. Obviously you can see the oil producing areas. We haven't delineated any of the geothermal things here. You'll see that in another slide later. We have a lot of temperature depth plots. This is just a compilation of some that are together. There is a separate file for each one of these holes with all of the data, the depths, and the plot for each hole. And this is one of the sites that we were very interested in. Many of you are probably familiar with that big heat flow anomaly in southern South Dakota and northern Nebraska. And this is the temperature log to the crystalline basement that we were able to get there. This was back in the 1980s when I was in Nebraska. But an oil company was drilling there, and they let us take over the hole and convert it to a heat flow hole. But this is just an example of what's there. The red line that you can see there is what the geothermal gradient would be if we just used the bottom half of that. In North Dakota, we have the bottom hole temperature map, drill stem test data, thermal conductivity measurements on cores, temperature versus depth data, and again, we geo-referenced that old geothermal resource map. We've had a lot of extra information that has come out of this, PhD theses, a new heat flow map, a new geothermal resource analysis, and so on. So there's a great deal that's come out of this. And just to show you, this is the North Dakota data set, bottom hole temperature data. This only shows a part of it. We haven't put in all of the Bakken wells. Most of those might be up to, say, 2 miles long. Once you get into bottom hole temperature, there is the same temperature you would get at just 3 kilometers down. So instead of being all the way out there, that's because they're drilled horizontally. One of the things that we have done is to work on corrections for the bottom hole temperature data. So on the left you see a plot. That thick blue line is an equilibrium temperature measurement that goes down to about 2,700 meters. And the bottom hole temperature measurements are the red circles. A correction, a standard correction for the bottom hole temperature data is shown in the little green triangles. And you can see here that bottom hole temperature data, these are the corrections. Notice a couple of data points here, corrections for those here. So what we have done is we've used our thermal conductivity measurements, and we're actually able to calculate what the temperature should be as a function of background heat flow, and that is heat coming in from here. And we've used 2 different heat flow values. The one that goes above the line is obviously too high. The other one that's right on the line tells us what the heat flow is in the area. And also, I'd just like to point out the big difference between what the real temperature is and what the bottom hole temperature data corrections and the bottom hole temperature data show. We're also able to separate out the temperatures on all of the formations that might possess water in the basin. This is the Madison wells. This is a temperature plot, contour plot of those Madison wells. And then finally, this is a comparison between the mantle heat flow map and the geothermal heat flow map. And what I'm saying here is that this is a USGS production. They show high heat flow here. This is caused by the Yellowstone hotspot, the track across there. You can see the cold of the Sierra Nevada. It's generally normal heat flow throughout the eastern U.S. This is from deep data, and it doesn't look at the very shallow things. Over here, we put in all of the data that we have in the database, and you get a picture of where geothermal resources might exist from shallow temperature gradient measurements. And I think with that, I'll stop.
Great, thank you, Will. I'm going to go ahead and unmute everybody, and once again, the reviewers have the first series of questions, and then we'll open it up to everybody else. We've got 4 minutes for questions.
Hi, this is Lisa. I just wanted to comment that it's very impressive contribution, especially you know, all the students involved, etc.
Okay, Rick here, Utah. Yeah, it is a massive contribution. We're looking at this map of heat flow of continental U.S. and you said shallow. So what do you mean by that? What's the red colors, obviously of high interest, apply to what depth range?
This is the entire database, so it could be anything from boreholes only about 150 meters deep to several kilometers. But that's produced from the entire database.
Okay.
Are there any other questions or comments from the reviewers? If not, I'll open it up to the DOE program officers and reviewers.
This is Dave. What was the reference on that that heat flow map that you're showing on the screen right now?
Can you see it at the bottom? Anna Kroll created that yesterday, and it's the heat flow database that you can get online at SMU.
Okay.
And it's also part of the National Geothermal Data System.
Okay.
So, Will, hi, this is Arlene. Great job. This looks wonderful. Appreciate all the great slides. We'll hope to have them on our NGDS launch page. I was wondering on the heat flow maps, one of the questions we always get is can we obtain the shape files associated with the maps in addition to the bottom hole temperature data. Is that possible to do if folks want to actually recreate the maps themselves?
Yes, we can do that.
And how would one search for that in the NGDS?
Oh, the shape files are not there. This map was just created yesterday, by the way. So
Okay.
I would have to go to Anna. She has them on her computer.
Okay, so
Arlene, well, we can work with Will. We can work with you on how to register the file in the NGDS.